Hello students, welcome to analysis of indeterminate structure class. Now we can take one more problem. The problem is analyze the beam shown by moment distribution method. Draw bending moment diagram, shear force diagram and elastic curve. You can observe here, this is the given continuous beam line diagram. Before starting the solution, you can analyze the given continuous beam, the support conditions and the loading conditions, and also the given span. See here, the support A is hinged support and support B is roller and support C is simply supported, and the span CD is overhanging span. This is the given problem. Let us see the solution for this. Which method we are going to calculate this problem? Moment distribution method. That means module 2. We know already the procedure for solving this by using moment distribution method. We already solved one problem by this method. The same procedure here also we should follow, but little conditions are changed here according to the support and the loading condition. Okay. Yes, the solution. The very first step is calculation of fixed end moments. Fixed end moment calculation, we know the formula according to the loading condition. So you can use the formula and calculate the fixed end moment. But here the span CD is there, no? It is overhanging span. That means it is not continuous, or it is not true support. Here on the span CD, or for the span CD, there is no true support. It is overhanging span or cantilever beam type. So here you can, how to calculate for this condition for this span, particularly for this span, how we are going to calculate the moment. Yes, here directly you can take the moment by applied load. How we are going to calculate? See, the given UDL is 30 kN per meter and the span length is, span CD length is 2 meter. So the load moment calculation is how the moment will act anti-clockwise. So the sign convention is minus 30 into 2. 30 is the applied UDL load. 30 into 2 is this span distance multiplied by 2 by 2. 2 by 2, why it is? If we are multiplying 30 into 2, it will convert to point load. But where it will applying at exact center. So the perpendicular distance is 1 meter. That means 2 by 2. Okay. The answer we are getting minus 60 kilonewton meter. Next, calculation of distribution factor for intermediate support. How we are going to calculate? We know the table for this calculating distribution factor. We should write like this. The joint here we are take joint B and joint C. Considering joint B, the member BA and BC. You can refer the figure. Considering joint B, the member BA and BC we are take. Okay. member BA and BC. For this, K is 3/4 of I by L. Why? Why K is 3/4 of I by L? For span BA and for span BC, according to the condition, the span BA, after completing this span BA, the beam is not continuous. So in this condition you should take 3/4 of I by L. Okay, we already know this condition. Very first class in this module I explained the conditions. You can once again you should recall the conditions. Okay, for on that basis here we are going to take 3/4 of I by L. Similarly for span BC, you can observe the figure. For span BC, after span BC, it is not continuous. It is not. Is it not? It is not continuous because it is overhanging beam and it should not continuous. So here that is the reason you should take 3/4 of I by L. Okay. Next, you can consider the joint C. Here you can observe, if you are going to consider joint C, the joint CB, the span you are going to take span CB. Here you can observe span CB or member CB and CD. Member CB, after member CB, the continuous beam is there. So that is the reason here you are going to take the K is I by L. Okay, and span CD or member CD, it is overhanging, so here that value is 0. Don't take the K value, K relation here. Okay, or K factor. Okay, next, after taking this factor, you can substitute the given dimension or given data. That means I is constant here, the L is the length of span BA. You can substitute that length and calculate the answer in terms of I. Okay, similarly for span BC, you can substitute the length and calculate the answer in terms of I. And finally you are calculate for this summation of K and calculate the distribution factor by using this formula. That means K by summation of K. K is 0.125I divided by summation of K means 0.275I. We are getting 0.45. I by I will get cancelled. So we are getting 0.45 and here 0.55. How we are going to cross check this distribution factor, it is correct or not? If we are going to add this distribution factor, it should come 1. See here you can observe 0.45 plus 0.55, it is 1. So it is, our calculation is correct. Similarly for joint C, you can substitute the data. The length is 5 meter and we are getting answer 0.2 I, and summation also same answer we are get. And after calculating this, the distribution factor for member CB is 1 and member CD is 0. Okay, this is the step for calculating distribution factor.